Net change part 2. So now we're going to deal with net change problems that have two functions. So we have you can say we have two rates of change here. Generally what happens is we have one rate of change that's going in, so it's adding stuff in, and then one that's going out, subtracting stuff. So we usually have an in and out function. Let's start. A tank contains 125 gallons of heating oil at a time t equals 0. So that's my initial value. During the time interval 0 to 12 hours, heating oil is pumped into the tank at a rate of this. So this is how much we're pumping into our tank. So this is in a little plus sign there. This is how much we're adding to our tank of heating oil. Again, notice it's a rate, gallons per hour. During the same interval, heating oil is removed from the tank at a rate of this. So this is going out. We're losing that. And again, notice gallons per hour. These are rates. So first question. How many gallons of heating oil are pumped into the tank during the time interval 0 to 12? So look what this one's telling you. It's how about are pumped into the tank. So I'm dealing with H of T here, right? This is all stuff that's going pumped into the tank. And it's only during the hours of 0 to 12. It's not saying how much total oil we have. It's saying during these hours. So that's a straight out integral. We're just going to integrate H of T from 0 to 12 dt. Again, notice how it says during the time interval. So no, I don't need to add the initial value. It's just saying during this time, how much are we adding in? So it's a straight integral. Then we plug this to our calculator. So y equals 2 plus. Now I'm showing you this one just because I want to show you that looks like a funky fraction. So I'm going to use the trick of alpha y equals, so I could put a fraction down. This makes me feel more secure about the way it gets plugged into the calculator. And then 1 plus natural log of t plus x plus 1. We don't use t. So again, I like to use the fraction button anytime I have a chance because this makes me feel more secure about that I plugged it in correctly. So I get that, and then we just integrate that. It's a matter of typing it in here, so I don't have to retype it over and over and over again. Actually, if I have time, I'm going to type this one off camera. Right, all I gotta do is go math 9. We're integrating from 0 to 12 of h of t. So remember that's for us, that's y1. So y1, and then press x. And our answer is 70.57. 0.71, if I round to the nearest thousandths. Again, if you're not sure, if you're worried about rounding, just write them all down, then you'll be fine. If I want units, remember we start off the rate gallons per hour and then we integrate it, so we lose that bottom, we lose the time, so it's just gallons, which makes sense. So that's A. Now let's talk about B. Is the level of heating oil in the tank rising or falling at time t equals 6? Give a reason for your answer. So let's think about this logically. So they want to know, is the level, if I have a tanker with heating oil, is more oil being poured in or more oil being taken out? So what they're asking is is this rate higher or is this rate higher at 6 hours, sorry. That's all they're asking. Am I plugging more in or am I taking more out at 6? So they're asking about a rate. Is the rate plugging in higher than the rate going out? So I don't need to integrate, I just got to plug 6 into both of these. So all I'm doing for B is, I'm going to check H of 6 and I'm going to check R of 6 and see which one was higher. If H is higher, that means I'm putting more oil in, so it's rising. If R is higher, then I'm taking more out, so it's falling. So we're gonna use our calculator again for this. Make sure you type in both functions. This makes life easier, and if you have any radians. And remember, the shortcuts to subbing them in is just pressing FOY1 and then parentheses. So parentheses 6. I get 5.39. 5.39 gallons per hour. Probably should add an extra, I should add an extra decimal point there, but whatever. And then we're going to do the exact same thing with R2, with R, which is my Y2. I typed it in off camera. So I get parentheses 6, and that's 8.31 miles per hour. So it is falling, right? And we're taking more out than we're putting in. So I would say falling. Actually, I should say heating oil in the tank is falling. Because R of 6 is greater than H of 6. That's it for that one. Again, right? R6 is bigger, and that's the oil coming out, then H6 oil coming in. So that's why it's falling. Now let's talk about C. How many gallons of heating oil are in the tank at time t equals 12? So this is a different question than A. A talked about during this period of 12 hours, how much is pumped in. Look at this one. How many gallons of heating oil are in the tank? So this is like total. This is saying after 12 hours, how much is in. So in this case, we got to do the whole add the initial value there, because how much should I start with, plus how much am I adding, minus how much am I taking out. So C is going to be like this. So we're going to do our favorite formula. We'll do the initial value plus, now my initial value here is 125 gallons. That's what we started off with. And then we want to add in how much oil we're adding. So we're going to integrate from 0 to 12, because they're asking about after 12 hours, so from 0 to 12 of H of T. And right, you could just write H of T. They know, the examiners know that what H of T equals, so you can just write H of T. Now, this is how much is being pumped in, but we also got to take some oil out. So we got to minus the integral from 0 to 12 of R of T. And this will tell us how much oil is in the tank after 12 hours, or at time t equals 12. Right? What we started with, plus how much we're adding, minus how much we're subtracting. So it's always plus the in, minus the out. And again, this we just plug in our calculator. Now we have it all set up already. It's 125 plus math 9 for integral, 0 to 12 of y1. X is always our variable. And then we got to subtract off the integral from 0 to 12 of the other function, r, which is y2 for us. Alpha F4, y2. Then we let the calculator do all the work for us. And we get 122.0257. Again, if you're wondering about units, right, we integrated from G of H, and we lose the time, so it's just gallons. That's how many gallons are in the tank after 12 hours. That's C. Now let's talk about D. At what time t from 0 to 12 is the volume of the heating oil at the least? So we talk about this a lot. It's a classic problem. Extreme values. Right? Anytime it's not the most, the least, it's an extreme value. And we know how to do extreme values. They're always in the same. They're always in the same way. We got to find the critical points plus the endpoints and plug them into the original function. In this case, it's kind of like the accumulation function. So I have my endpoints, 0 to 12. I don't have my critical points yet. We got to talk about that. But also, do I have an original function? What am I plugging this into? Right? I'm trying to find the total volume of the tank. So my original function is actually very similar to this guy. That's my function. So we have to make our own function here. So I'm just going to put volume of t equals. So if we want to find volume of the tank at any point, it's essentially this formula here. How much do we start with? Our initial value plus the integral what we're putting in. So from 0, now again, I don't have actual time, so we're just going to put a t up here. H of t. And I can't use t because I already have a t in my variable here. So instead of h of t, I'm going to put h of x. It's a dummy variable. Minus how much I'm taking out, which is the other function. R of x dx. And that's how we come up with these functions. Anytime we do one of these net change problems with two integrals, at two rates, probably better to correct. It's always the same thing. The v of t equals my initial value plus integral of the in minus integral of the out. And that'll give us our total after a certain time. So that's always going to be the formula, right? So initial value plus integral in minus integral out. So we have that here. So that's my original function. I'm going to plug 0 and 12 into that. And I've actually, some of these are easy. If I want v of 0, just plug it in. Well, remember, anytime there's 0, anytime the limits match, you get 0, 0. So I have 125. That's how many gallons we have at 0. Or initially. V of 12. This is one we just did. And we got 122.0257 gallons. So that's a little less. We're actually looking for the least. So right now that's the liter in the clubhouse. But we haven't found the critical points yet. So how do we find them? Well, we do it the same way we always do, right? If you want to find the critical points, you always take the original function, or in our case, v of t, and set the derivative equal to 0. So let's first, we got to find the derivative of this guy. So let's do it right here. V prime of t. Take the derivative like we know how to take a derivative. Derivative of 125, 0. Plus, derivative of integral, cancel each other out, and I just get h of x, or h of t in this case, minus the derivative and integral cancel out, and I just get r of t. And I want to set this equal to 0. Because, right, we're going to take our derivative set equal to 0. So, essentially, we just have this. So, those are our critical points. Or, on our calculator, this would be y1 minus y2. So, we get this. Or, you can think about it as y1 equals y2. Now, the benefits to each one. This one's a little easier to find the intersections. This one tells you which is the min and max. So this one's actually the preferred method. You just want to graph this. So if you're really good at calculators, this is the way you want to go. Right, so if I my calculator out, we're going to make a third equation right here. That's y1 minus y2. And again, we'll talk about the benefits of this real quick. So alpha y1 minus alpha y2. No matter if I'm going to graph these, I really don't want to see that these graphs, so I'm going to press enter on their equal sign so they don't show up. And before I hit graph, let me change my window. We were going from 0 to 12, so make sure we were going from 0 to 12. I did this earlier. So you're graphing something like this. So what's the benefit of doing this one? I know it has to regraph into make a new equation. The benefit is, though, I get to see my local min and max. So right here, I can now tell that's a local max, right? It goes from positive to negative. So that value right there, local max. I don't care about the local max. I'm going to try and find the least value. So maybe this value here might be the local min. So let's find the 0. There we go, 2. So remember, all you have to do is move your graph. If you're not sure where your thing is because your graph's funky, just look right here. It'll tell you where on the x-axis it's close to. So here's the 0. Remember, we go a little left to make it a little left bound. A little right to make it a little right bound. So calculate the search in that little area. Hit guess. And we get this. Now, before we copy it down, because I do have the answer, it is, well, I have a critical point. I'm not sure if it's the answer to my question. Remember, we want to store this guy. So a little review on how to store. Remember, we quit, we hit store, and we type into any one of these variables we want. So I'm going to put alpha A. So now right here, I'm going to set that equals A. So that's my critical point. I'm going to check that critical point for our answer here. So we're going to do V of A. I can do that as long as I wrote what A is. I can do that. I get 125 plus the integral from 0 to A of H of dt minus the integral from 0 to A of RT dt. Typed into our calculator. So I'm going to get 125 plus F9 0 to A, so alpha A of y1 x minus math integral 0 to A alpha A of y2 x. And that would give me, let's move this around here, 120.73. 381. And that's the lowest. So that's my least value. So my least value is 120.7381 gallons. Remember I said show analysis that leads to a conclusion? It's all that work right here. All of this. Right, that's how we always do find the least or max or extreme value problems. It's always critical points plus endpoints into the original function. Right, and we always find critical points the same way. Take the derivative set equal to 0. Derivative in this guy's a little funky because it's this function. You take a derivative of that function, it's 125 is 0. Derivative of this function is h. It's just h because these cancel out. Derivative of this function is canceled out, and you just get r. So you could solve it this way, right? y1 minus y2. That is the benefit of doing that, is that you do get to see the max and min. If you just set them equal to each other, you just see intersections. You're not sure which one's the local max or local min. So I actually would prefer y1 minus y2 because you actually see local max and min. Anyway, that's this problem. Let's do one more and then we are done. Water is pumped into an underground tank at a constant rate of 8 gallons per minute. Water leaks out of the tank at a rate of rad t plus 1 gallons per minute for 0 to t, for t between 0 and 120 minutes. At time 0, the tank contains 130 gallons of water. First, let's talk about what's going on. So we have a tank here. Let's draw a little thing like this. And water's flowing into that tank. Well, first, there's actually 30 gallons already in the tank. Alright, so there's 30 of these guys, 30 gallons. And then water's flowing in at a constant rate of 8 gallons per minute. So we're going to say, I'll write a little equation here. Let's say flowing in, so I'll put, I don't know, P. P of T equals 8 gallons per minute. That's my in function, my plus function. So you have water going in at this rate, 8 gallons per minute. And then water is leaking out at a rate of rad t plus 1 gallons per minute. So the right equation for that, let's say LT, a function for that. Leak, so LT is rad t plus 1 gallons per minute. This is what's leaking out, so minus. So that's what's going on here, right? We have one function going in, one function going out, and we have 30 gallons to start off with. So let's see the first question. How many gallons of water leak out during the time from 0 to 3 minutes? And I know it's only asking about water leaking out, so this guy, and it's not a total, it's just saying in this time between 0 and 3 minutes, how much it leaked out. So I'm just going to straight out integrate this guy from 0 to 30. Now here's the thing about this problem. If you notice, we have 8 and we have rad t, so most likely would be by hand. So we're going to do this without a calculator and go old school for this. So we have integral from 0 to 3 of rad t plus 1 dt. And we have to integrate this. Again, we're going to do it by hand. So you can do a u sub if you want. I'm going to do reverse chain rule because this is linear. So first, let's rewrite it. 0 to 3 of t plus 1 to the 1/2 dt. Then we're going to do reverse chain rule on this. So I'm going to add 1 to the top of this, 3/2, divided by new power. So I get t plus 1 to the 3/2 over 3/2 times 1 over derivative of the inside. My inside is the derivative, that's just 1. We're going from 0 to 3. Simplify it a little bit. So that 2 goes to the top. T plus 1 to the 3/2 over 3 from 0 to 3. Now I cannot leave it like this. I do got to simplify it a little bit more. I know how I just said AP Calc, you can simplify and be done with it, but this is not simplified enough. You have to plug the limits in. So if I want a full answer, it will be t to the 3 plus 1 to the 3/2 over 3 minus 2 times 0 plus 1 to the 3/2 over 3. Now, I probably could, you could leave it like that, but I'm OCD. I'm going to simplify it a little bit more. So I get that. This is just 1, and 1 to any power is just 1. So this is actually just 2/3. And that is my answer in gallons. Right? Because we integrate, so we lose the bottom part. So that's it. Again, you can leave it at that. Fair game, you don't have to simplify. That's as far as they expect you to go. It's like here is fine. This is not fine. So that's A. That's the number of, that's the amount of gallons that's been leaked out. We're going to need that for a later problem. So now let's do B. So for B, I cleared some clutter. I wrote the answer for A there because we need it. I think we will. So let's see what B is asking. How many gallons of water are in the tank at t equals 3 minutes? So again, when they ask this question, it's one of our favorite questions. They mean after 3 minutes. So like how much total is in the tank after 3 minutes? So when they ask that question, we always do our new favorite formula, which is the total amount, which we have the initial value plus the integral of what's in minus the integral of what's out. Alright, so anytime they want like a cumulative amount, it's always this formula: initial value plus in minus out. If they want between a certain time, we just integrate. That's like that, like A was. So our initial value up here, 30 gallons. Integral of in. In is this guy, just straight out 8 kilometers. 8 grams per minute. Gallons per minute. Man, what's supposed to me? And we're doing that from 0 to 3. dt minus what's out. So 0 to 3 of square root of t plus 1 dt. So we just gotta integrate this guy. Now again, we actually just did this one right here. So I actually have this answer. I gotta figure out what this answer is. Well, this is a basic integral. Integral 0 to 3 of 8 dt. Well, you just add the variable to it. So it's 8t from 0 to 3. Then top minus bottom. 8 times 3 is 24. We get 24. So this is 30 plus 24 minus the out, which we found out was right here. So this is parentheses. Can't be sloppy. Minus 2/3. And that is my answer in gallons. So that's how much total is in the tank at 3 minutes. It's the initial value plus what we're adding in minus what we're getting out. We're losing. So that's B. C. Write an expression for A of t, the total number of gallons of water in the tank at any time t. So this is essentially what we just did. Just instead of putting 3 here, we're going to put a dummy variable. We'll put x or k or something. That's all it's asking. Actually, I wish they would ask this before we ask this B. Because all it is saying, hey, what's the expression for the total number of gallons at any time? We have that expression right here. So C's going to be real fast. C is just the initial value, so A of t, the initial value, which is 50, plus the integral of n, which is P of t. Again, as long as I could write P of t, as long as I name it, and as long as I wrote it down somewhere. From 0 to t. And actually, since I wrote P of t, since I wrote t up there, I have to write something like x down here. Minus integral of out. And that would be, for me, L of L. So that would be my formula. Again, you could equally write if you wanted to, or you could write it just straight out, kind of the way that they gave it to you. 50 plus integral from 1 of t of 8 dx, again, has to be a different variable, minus 0 to t of square root of x plus 1 dx. So you can also write it like that. Either way is fine. Again, writing P and L are fine as long as you wrote it somewhere on the paper above beforehand, so they know, okay, that's what P and that's what L are. So that's D. Now let's talk about D. At what time t for 0 to 12 is the amount of water in the tank a maximum? Justify your answer. So right, another one of these extreme value problems. So hopefully you know by now we know how to do an extreme value problem. Right, so if I want an extreme value, it's critical points plus endpoints. And we're going to plug into our original function, which is A of t now. Now, I have my endpoints. They told me from 0 to 120. My critical points I have to find. So we always do it the same way, right? You take the derivative, set it equal to 0. In this case, we're going to take the derivative of this guy. So the derivative of 50 is 0. Plus the derivative of this. When derivative and integral cancel out, I just get 8. Minus the derivative of this guy. These cancel out, and I get radical x plus 1 equals 0. Again, this is all by hand. So actually, I should solve this by hand. So add this to both sides. So I get 8 equals rad x plus 1. Square it. 64 equals x plus 1. So 63 equals x. So that's my critical points. So I gotta do each one of these. I gotta figure out what A of 0 is, what A of 120 is, and what A of 63 is. And whatever has the highest value is my answer. And actually, let's look at the question. It wants to know the time has the highest value. So my answer would be either 0, 120, or 63. And actually, I think I messed that up earlier, not thinking about it. The one before. I put 120. The time was the answer. So the actual answer should have been A, which is 11.318 hours, I think. That should have been my answer there. Because actually, it wanted the time. At what time t. So always watch out. I messed that up here. So it would have been hours. Same thing down here. They want the time. So let's finish it. I figure what time gives us the maximum. So all I do is plug that into the formula. So it's 50 plus integral from 0 to 0 of 8 minus integral from 0 to 0 of radical x plus 1. By now we know these just are 0. I just get 50. A of 120. So that's 50 plus the integral from 0 to 8 of 120 8 plus the integral from 0 to 120 or at x plus 1. I actually got to integrate that guy. Let's erase this. I'll give myself some space. We'll do a 63 down here. So this is 50. That's just 8 times 120. This essentially is just this formula, but with, instead of 3 plus 1, it'll be 120 plus 1. So that would be, what is that, 2/3? Yeah, 2/3. 121 to the 3/2 minus 2/3. And same thing with A63, I would get 50 plus integral of 8 from 0 to 63 minus integral from 0 to 63 of rad t plus 1. Which if I plug in the same formula, same idea, 8 times 63 minus same idea, 2/3 of 63 plus 1, which is 64, so 3/2 over 3 minus 2/3. Whew. So to get those two, now I have to figure out of these which one is the max. Maybe these are actually smaller than that one. Do a lot of algebra later, like 121 to 3/2. That's square root of 121 with 11. 11 to the third times something times 2/3 minus 2/3. I'll tell you after a lot of algebra later, this would be the right answer. So that would be my max. And again, watch the question. They didn't say what the max is. What time is the max? They do that so you don't have to actually simplify it all the way. You can just kind of look at it and try to figure it out. But the max would be at time equals 63 would yield my max. And that would be my answer. So that's it. Practice your algebra. Look at this one. We'll talk about it in class. And that's it.